Okay, so this is Calculus 30. This is in the Red Stewart textbook. This is 10.2. This is number 1N. All right. Now what this question is asking is to find the area of the region contained within these three lines. Okay? And so here's the three lines. We've got x plus y equals 1. We have x plus y equals 5. And we have, actually there's 4 lines, I guess. Y equals 2x plus 1. And y equals 2x plus 6. All right? So these are the 4 lines that we want to find the area between. So what would be a good idea is to quickly sketch the lines. Now over here I have the solution from the manual, and it has the sketch on there. And that's going to be important for a few reasons, because you need to find out where the intersection points are for these lines to know where the boundaries are for this area. Okay? So in order to graph them, what you could do is just do a simple XY table and, you know, graph the x-intercept and the y-intercept maybe. That's a good place to start. So if x is 0, then y is 1. If y is 0, then x is 1 over here. Right? And of course over here you could do the same thing. If x was 0, y is 5, and if y is 0, x is 5. Over here, let's see. If x is 0, 2 times 0 is 0 plus 1 is y, so that's y is 1. And if y is 0, then it's negative 1/2. Very good. Okay, and finally, over here, if x is 0, y is 6. And if y is 0, then what do we have? We have negative 6 over 2 is negative 3. All right. Now, if you put all that together, you get these lines. So let's say the first one here, if this is in blue, we have 0, 1 as a point, and then 1, 0. So, yeah, I guess this would be 1, 0 here. Okay? So then you draw that line. Boom. That's this bottom line right here. And this is the equation when y is isolated. Over here, 0, 5. So that's this point right here. And then 5, 0, which would be down over here. And that's this looks like this line right here. Okay? So, yeah, this will take you about a minute and a half or 2, you know, just to kind of give a rough sketch here. Then you can kind of see where you're at. So 0, 1, and negative 1/2. So 0, 1, negative 1. That's this line right here, right? And then the 2x plus 6. I'll do my colors. 2x plus 6 there. That's 0, 6. That's 0, 6 right here. That would be this one right here. And then negative 3, 0 right there. So that's this line to the left. So you've got your 4 lines sketched out and graphed. Now at least you can see where the intersection points are, and you could calculate these 4 intersection points pretty easily. You don't have to do it from the graph. You could do it from the equations, right? You could let the equations equal each other and solve for the values. However way you do it, you want to solve for the intersection points. So the points of intersection, let's see. They did the 1, so that's this first one, and this one over here. They found the intersection point there. And here they are listed here. So x equals 0, that's this one. X equals 4 over 3, that's this point right here, the x value for this point. X equals negative 6, is that 5 over 3 or 6 over 3? Negative 5 over 3. And negative 1/3.
How do you solve for the intersection points again?
Negative 1/3. Okay, what you can do for intersection points, right, is to write them in terms of y equals, and then let them equal each other. So that's kind of what they did here. Let me just show you here. We can make some space. Okay. So for this one here, this is actually y equals negative x plus 1, right? When you get that y by itself. This one is y equals negative x plus 5. So if we want to find the intersection point here, we let negative x plus 1 equal negative x plus 5. We're letting the y values equal each other, so we're going to find out where they meet.
Okay.
Now, the problem is that these have the same slope. So if you did that and solved for x, guess what? You get 1 equals 5. So there's no solution there. Okay? And that's the two parallel lines. So we don't want to do that. Okay, that's a bad example. But if you come across this, that means they're parallel. There's no solution. So let's take this one and another one that we can actually find an intersection point for. Let's do the 2x plus 1. Okay. So y equals 2x plus 1. And then you simply let them equal each other. So negative x plus 1 equal 2x plus 1. Let's add x to both sides. You get 3x over here. Let's subtract 1 from both sides. Equals 0. X equals 0 divided by 3 is 0. So the intersection point there would be x equals 0 right here. Okay? Any other questions so far? Quick sketch. Find the intersection points. Now, if you had a graphing calculator, which you're not really going to have one here for a test. But if you had a graphing calculator and you did a question like this, you could use the graphing calculator to find out where those intersection points are if you remember how to do that, which we'll talk about that another time. All right, so we have the x values here. If I could just clean up this graph just a little bit now. Those x values are going to represent the different sections that we're going to use. So that's kind of a tough diagram because it's all filled in with black. So okay, so let's just sketch that real quick over here. Okay, so here's the graph, and then here's your intersection, the x values for your intersection points. Okay, so you're right, this is a long question. But now we're ready to go. See, now what we have is this. If I draw a dotted line here, okay, down to this x value, and then use this end point here, I have two lines only, and the area underneath, in between those two lines, right? And I can find that as area number 1. Then I can look at this x value intersection point, and I can find an area number 2 here. So there's a top function and a bottom function. And then finally the third part would be this area right here. Okay? Maybe I'll zoom in there a little bit. And as long as you've identified what lines these are, you can then do 3 separate kind of area problems to give, and then add those areas up.
Oh.
So which was this line right here?
That was 2x plus
Y equals 2x.
plus 6.
2x plus 6? Is that the... Okay. Is there a 2x plus 6 there?
Right one.
Okay, yeah, 2x plus 6. And then this one was y equals 2x plus 1. Okay. And this one over here was
Negative x plus 5.
negative x plus 5. Okay, good.
Negative x plus 1.
Negative x plus 1. All right. So for the black, okay, so we want to find the area under, so we've got the top function here is this one, 2x plus 6, right? And then the bottom function, if you subtract that, is going to be negative x plus 1. And you want to find the area there between negative 5/3 and negative 1/3. Okay, so there's our combined function now. We're going to find the antiderivative and evaluate the area there underneath. So I'll do that one with you. So this new f of x here is, so what's 2x minus a negative x? That's 2x plus x, 3x, and 6 minus 1 looks like 5. That's the new function. So we want to take the antiderivative of that function, which equals what? 3 over 2x squared. Good, good. Plus 5x. 5 just becomes 5x. Awesome. So now we want to evaluate this between what?
-5.
Yeah, negative 5 over 3 to negative 1 over 3. And that will then equal our area 1 in black. Okay? And then you do the same thing for the red area using these two, right? Using those two functions as the high, the upper and the lower. And then, sorry?
Is it those two functions?
Yeah, because look at, here's the top part and here's the bottom part.
Okay.
That's for the second area. And then the third area uses this function and this function right here. Okay? So, yeah, go ahead and finish that off, and then we'll come back and I'll give you a few minutes to do that on your own, and then I'll come back and let you know what the answer is. Is that okay? Can you take it from there?
Yep, I can.
Okay.
It's always the...
So as you can see here, the answer, once you've combined the areas of those three sections, 1, 2, and 3, the total area should be 20 over 3 units. 20 over 3 units.